The Type 164 is the first oscillograph offering made by Dumont Labs, who prior to that was famous for inventing the magic eye tube. It's used in all kinds of radios and test equipment. After the 164 came out, Dumont became the leader in oscilloscopes and were essentially the Tektronix of their age. They also went on later to have one of the first television networks in the United States. I guess that's clearly an aftermarket add-on to the case. And that's an emergency handle on the case that's in a state of emergency itself. And the top is looking pretty bad, but the paint on the side kind of shows how nice it was at one time, the nice texturing on it. It's just a shame that it's peeling off so badly. Looks like I might be able to retain some of the feet on the bottom of the scope. They appear to be in good shape. So, and when I look on the inside, it's just, I really like the way that they've done it. They have these boards that they mount, most of the, or many of the components on, and then the wiring is kind of done in the back side. It's just, a little bit of a professional touch that's better than what I had been exposed to when I was restoring my ICO 460. The transformer is a monster, as they all were back in those days. And this is a view of the back of the scope leading up to where the CRT plugs in. On the inside, you can see, a lot of old-fashioned tubes, shoulder type. The two in the can up front have the caps on the top of them that are for the control grid, and there's the CRT, obviously. In this case, it was a 3AP1. You're looking at the 164 next to my ICO 460, which I had just restored. It with its 5-inch CRT looks like a monster next to the 164, but the ICO was, developed some 20 years later or so. After I started cleaning it up a little bit, I noticed that some of the knobs weren't working, so they couldn't even be repaired, so I was going to have to replace them. And I also noticed that the CRT itself was broken, so that's where I start. The post office is going to be delivering my replacement CRT a few days early. I mean, I wasn't expecting it until Monday or Tuesday, and it's Saturday, so I'm going to be getting it a lot earlier than I thought. So this morning I've been going through, checking all the stuff. Here's the tube that they're replacing. This is a 3AP1. Even this is not the original one that came with this device. The original one was called a 34XH. And they put this one in, and for some reason they managed to break it. Break this connection here between this cap and this and the bulb part of the thing. So I don't know, it's probably shorted or something inside there, because that's why it was coming and going. I don't think the vacuum is destroyed, so maybe it's even possible to repair it if someone knew how to take it apart. But so I'm getting a new 3AP1. All the sources I've been finding is that it's a good replacement for the 34XH. But when I did have this plugged in, and when it worked a little bit, I noticed that the display was a little bit cocked, and that I'm kind of a little bit concerned about, that plug in the back that you see back there doesn't line up perfectly. So I may wind up having to make adjustments to that after I get the tube in. In the meantime, I did order a new set of these chicken heads, but it's a different, if you notice, they're completely different. I haven't been able to get those two off yet, and I'm not sure when I'll do it. There's no big hurry. You know, I just have to figure out a way to get the job done right. So these are plastic. They're not as nice as the old Bakelite ones, but you know, they look pretty good. And that's the way it showed in the original documentation, that what they called the red ones, it forms a cross in the middle because they say that those are the five used most often. And yeah, I guess, you know, that probably makes sense, but that's how it was originally designed, was to have the red ones form a cross in the middle like that. So I've been going through cataloging where all of the parts are at, so that if it does look like it's beginning to show signs of life, I can start figuring out what, if anything, I need to start replacing. Um, and I'm actually making a drawing of it, because what they did was kind of interesting. You know, they have a couple of boards where they put the components at, which makes for a very neat and organized arrangement of the parts for a point-to-point type system. But at the same time, it makes it, you can't just trace things by looking at it. You have to get out the ohm meter and trace it from point to point, because you can't really see where the wires are wired to on that back plane unless you tear it all apart. And I didn't want to do that. So um, anyway, the other thing that I wanted to do was buzz out those pens for that CRT. I did that this morning. So the new CRT has come in, and I was just comparing it for size against the old one. Um, Same size, everything looks right. Um, and the top is a lot tighter than the other one was. The getter's pretty dark, but I read an article somewhere that the color of the getter doesn't really mean much, you know. It just depends on what chemicals it was getting out while they were vacuuming. So I'm going to be real careful about installing this. Very gently rocking it into place, and only temporarily. I'm probably going to take it back out. I've gone through today, and I've checked just about everything I can to make sure that it seems like I won't have any problems. So I'm going to plug it in and see what happens. I thought that now might be a good time to take a look at the drawings and kind of familiarize ourselves with the with what we're going to be working on with this oscilloscope. What you see here is maybe not the first drawing, but it's one of the original drawings associated with the device. It's dated March of 1937, and it's included in the manual for the scope itself. When you look it over, you can kind of tell that it's laid out and arranged in a way that's pretty similar to the way that at least the ICO was laid out. I can see in the upper right hand corner that there are some plates with some vertical and horizontal terminations on them, and they're just below that you can see some grid lines. So that's obviously the CRT. Below that there's a cathode, and you can see where the power hooks into that. So we're looking at the CRT1. It's labeled as a 34XH. Moving straight across to the left, you can see vertical inputs into another tube that you can see the grid lines, and you can see the cathodes associated with it. So this is obviously has something to do with the vertical deflection. Below that, you can see horizontal input into another tube with grid lines. You can see the cathode. Those are both 6C6 type of tubes. So that has to do with the horizontal. Below that, you can see an external input, so that's a sync input. So that's the sync circuit And down below that is another tube. It's labeled at 885. This seems to be associated with an array of capacitors, which we know will be the frequency selector. Off to the right of that is a transformer with a whole lot of secondaries associated with it, and two 80 tubes that are used to rectify the output. Interestingly, you can note that it really just handles 115 volts, so this is only for domestic consumption. So that's the 164, but it's a segue into another drawing that I found on the web that is a little bit better, something that is more conventional and has a lot of symbols that more people are familiar with. But if you look down at where they look at the windings for the power, it's suitable for both 115 and 230 volts. It can just be, you just have to change the way that you wire that in. And it's probably because this is good as an export model. There is no 164A, B, C, or D. There's just a 164 and a 164E for export, I would imagine that's what it's for. But everything else is laid out in the same way. In the upper right-hand corner, you can see where the CRT is. In this case, it's a 3AP1, and basically it's laid out pretty much the same way. There's a few other things to notice on this. This drawing is better in several ways because it includes all of the specs on all of the components. So you wouldn't necessarily have to be referring back to the parts list every time you wanted to know, I'm looking at R11, what's the spec on this thing? That information is right on the drawing. That's very handy. Yeah, it's a much better drawing. Also, it's got voltages listed on a lot of the pins on the tubes, as well as voltages out on resistor runs in the middle of the drawing. So the question becomes, would I be able to use this 164E as my source material for troubleshooting it? So, naturally I have to go through and check everything to find out whether or not I can use it. And right off the bat, I start seeing things that components, hardware that's in the 164E that does not exist in the 164. If you look in the middle of this drawing right here, you can see that there's an L2 and L3 induction coils that do not exist in the 164. To the left of that, there's a couple of capacitors, C21 and C22. Down below that, in the lower left, there's an entire little circuit there that called a test signal that has an external binding post that you can hook up to. That does not exist in the 164. And to the right of that, you can see a capacitor C20 that is associated with the sweep ranges there. If we go way up to the right, the top right, you can see just below and to the right of the CRT, there's one more capacitor there. That does not exist in the 164. The rest of the stuff that you see in red, most of it is just differences in the specs for the components. For instance, they all have R1, R9, R10, R11 components, and they're both sitting in the same place, but they may have different values. So the one caveat that this brings up is, are those voltage levels going to be valid for the 164? But this is what we have to work off of, and it's probably the best information that we have available, and more information is always better than less. I'm going to go ahead and derive a drawing based on it. In fact, using that drawing and just editing out the components that do not exist in the 164, and changing the specs of the components that do to the values in the original drawing and the original parts list. And this is what I came up with. It looks pretty good. As I say, I'm not 100% sure that all of the voltage levels that are shown on there are going to be right for the 164, but some of them will be. I mean, there are others there that there's no reason why they wouldn't be correct. So this is what I've got to work with to start out with. And from that, I can take voltage levels to establish a baseline to work off of. And what you're seeing here is it kind of shows that most of the voltage levels that are defined are on the pins on a lot of the valves. And what I have circled in red here are things that deviate enough from what is spec'd as a voltage level that it may be something that we want to go back and revisit if we continue to have problems that we can't seem to get rid of as we're working through this thing. The other thing I want to point out is that, yeah, V1 through V6, those are tubes or valves, but I have one group of readings that I just labeled inputs because that's just a name I grabbed out of the air. What it is actually just a couple of resistor runs. One of them is R14 to R4, and then there's another resistor run, a separate one from R1 to R3. And what you can see there is that the R1 to R3 looks like there may be some issues there. So anyway, we have a baseline, so we can move forward and start to address some of the issues. I'd like to talk just a minute or two about the methods and procedures I use and cover the basic approach. This isn't the only way to restore vintage equipment, but it's how I've been working it. These methods are based on what I've seen others do online and what I did during my working life. I use several different plans of attack that rely on documentation and experience. The first approach is to verify and address power issues, which we started to address in this slide. The second is to take measurements on passive components and replace those that are out of spec. In this slide, I have lifted one leg of several capacitors to take them out of circuit. Their capacitance is measured, and those that are out of spec are replaced. I do this with all electrolytic and paper or wax caps. In this image, I'm doing the same with a couple of resistors by taking ohm readings against the banding on the resistor. Often resistors will only be checked after diagnosing a problem, though. Finally, a third plan of attack is by identifying performance issues and troubleshooting them. This slide shows an issue with the scope where one of the channels on the sweep selector wasn't working. We'll pursue this problem to illustrate how the drawings shown earlier are used together. The schematic drawing we created earlier provides a functional view of how the scope works. On the schematic, we locate the sweep selector and locate the channel. We can see that the second to lowest channel is controlled by capacitor C14. Next, we locate C14 in the cross index. Looking across to the right, we see that on the chassis bottom pictorial drawing, C14 is located at coordinate D3. We then go to the pictorial drawing, locate coordinate D3, and find that C14 is nestled between two other wax capacitors, C13 and C15. Finally, we go to the device and find the component buried beneath those two wax caps. We have successfully related a malfunction to a logical, physical, and real-world component location. The process can be reversed. If, for instance, we find that the capacitor in the middle measures out of spec, we can look it up in the pictorial diagram. Here we see that the capacitor in the middle is C20. We can go back to our cross index and see that C20 can be found at coordinate D4 in the schematic. Looking again at the schematic, we find C20 at coordinate D4, and recall that it was the capacitor that was not in the parts list for the 164, but was nonetheless installed on my machine. I won't be covering these gymnastics for the rest of the video, but I thought it might be worthwhile to describe one of the processes that happens behind the scenes. Okay, all of the capacitors I've tested so far are way out of spec. And I've gone in and replaced 4 that I had in stock. But really, I'm of the opinion that there's no way to salvage any of these wax capacitors or any of the electrolytics. So I put in an order to Antique Electronics and DigiKey to get the parts I need, including a bunch of resistors. I haven't had a chance to measure too many of those. There's a few of them that are out a little bit, but the capacitors are at least 90% out of spec, you know, so and some of them can't even be read at all. Some of them bounce around. So I think that you know, the conventional wisdom applies, where you just go ahead and replace all of those capacitors. So I put in an order. I have noticed a couple of improvements, you know. Now we are beginning to see a little bit of the intensity working. I'm not having to go too crazy with the knobs. Now I've got a little bit of vertical gain, and it makes a little more sense than it did earlier. But you can see that the trace is still crooked. That may be a physical thing, it may be electronic, but we'll see. Anyway, once I get the parts in, I'll go to town on that stuff. As long as I'm still waiting for parts, I decided that I would go ahead and replace a couple more capacitors from stock that I have, and it's caps C13 and C15, which are located down in the sweep range selector. Okay, so it's been 4 days since I ordered the new hardware capacitors and resistors, I mean, and they won't be here today either. So I've been trying to address the issue of the CRT being cocked the way that it was, and one thing I realized is that it was upside down. They had replaced it with a 3AP1, and the way that it was wired and the configuration of the socket was for the 34XH, and there are differences. I guess it must be that the 3AP1 is upside down compared to the original CRT, which I've looked around, I can't find any 34XH CRTs anywhere. But what I did find out that, yeah, okay, I could rotate that socket back there 180 degrees and turn it around and sort of resolder the leads a little bit. And it did, you know, now it seems like the controls are operating the way that I would have expected them to. But, you know, I still have the problems that I need to work on with the capacitors. You see how this is? It's like I can't even go halfway on vertical positioning and see the trace at all. I have to have it turned all the way to the left and bring it up as high as it'll go in order to get it just to there, and that's still not where it's supposed to be. Horizontal alignment is even worse. It goes That positioning doesn't look right at all. I'm going to have to wait until I get the capacitors in to find out what is right. But, you know, the gain seems to work fine, or at least the vertical gain does. And the horizontal gain, if I turn it to the left now, it goes where I would have expected it to go before. I decided to go ahead and take some more voltage readings, given that we have changed out the 6 capacitors coming out of stock. So before we get into the next round of replacements, I took some readings and found that V1 had gotten a little bit worse, probably because the intensity started working, whereas before it wasn't. Whereas V2 and V3 have gotten a little bit better, and one of the readings on V4 looks like it's gotten a little bit worse. By and large, the rest of them are showing no signs of change at all. Before we move into the next round of replacements, I want to just show which capacitors we're planning on changing out. It's mainly centering around the horizontal and vertical positioning, as well as the output of the horizontal and vertical amplifiers. Okay, I just finished changing out all of the capacitors in the vertical and horizontal sections of the scope, and for the first time I've got a signal that goes all the way across the display, and I can do vertical in both directions now. Vertical positioning, I mean. So the vertical positioning works. Vertical gain is working now. It was actually working before. That's the only way I was able to be able to see anything at all in the early going. But the horizontal positioning is working now. Before it wasn't budging an inch. And horizontal gain is working now. So we've got most of the functionality is back. I think I've still got some issues that I need to work out in the sync section and the sweep. Well, you can see here as I adjust this one doesn't work at all. This one's working. I would have to sync it up, but that one's working. All of the other ones are working just fine, or they seem to be. One thing I do notice, though, is that if you look closely at this trace, it's got astigmatism as we move further to the right. It may be that it's got a better focus right in the middle. It's hard to tell. Let me try to focus for the middle. And it could be that this is. But anyway, we made some progress. Okay, so what still has to be done is the filter capacitors. I haven't changed those yet. There's a big one for the high voltage stuff that goes directly up to the CRT. I think that one goes up to 1200 volts. Then there's a couple of fairly good sized ones that are associated with a good, but still there's 3 capacitors that I need to change out in the sweep and sync section. So I'll do that and see if that helps out with any of this. I'm not sure how it might, but I do know that on the ICO that some of the issues I had with deviations, you know, from left to right did have something to do with the sweep section. So we'll see what happens. After changing out the capacitors in the sync section, it did not get rid of the astigmatism on the right hand side of the CRT, but it did. This channel is now working at least. Now I have a signal in there. If I lower the frequency down that I'm feeding it, yeah. So it's working pretty good. You can see it kind of dancing around a little bit, even though I'm syncing right off of the wave tech. Still have the filter capacitors to replace, and that might help that out a little bit. It may be enough for one day, and I'll just save the filter capacitors for tomorrow, although I do have it set up so that I can replace them fairly quickly. So anyway, a little step at a time. Here you can really see what I'm talking about so far as the astigmatism issue here. If you look over on the right hand side, it's quite a bit more blurry than it is on the left, and there's really nothing I can do to bring it back in without making the rest of the image really blurry. So yeah, look how thick the line is on the right hand side, and how thin it is for the pulses that are, not the pulses, but the waves that are entering into the viewport. Okay, so I just finished changing out the last of the capacitors, or at least all of the ones that I'm considering replacing. I have I think I've changed out 16 capacitors, and there are 4 left in this machine, but they're all micas, and they seem to be in pretty good shape, you know, from what I can tell. I'm not really seeing much of the functionality. It's not working. Also, at the same time, I went ahead and straightened out the trace a little bit more, and the way I did that was just by, I had a little bit of adjustment that I could use, because I made modifications back there so that I could turn it a little bit more, and so that it's now at least level. But you can see that even with the last capacitor changed out, I still have the issue of astigmatism. I haven't changed out any resistors. I suppose that's entirely possible, but before I do that, I'm going to go through and check all the voltages again to see where we are now that all of the capacitors have been replaced. All of the big bulky capacitors, and of which there were quite a few of them. What else? Oh, the way that I leveled the tube out is that I basically just took all of the sources off of it, and I had a straight line that I could use. Actually, all I had to do in order to get to that is just power off the wave tech, and I use that straight line. I put a couple pieces of tape on either end on there, and basically it kind of showed that it was still cocked a little bit, and I just shut the power off and everything and just rotated it until those 2 pieces of tape lined up with the top of the focus and intensity knobs, or not knobs, but they're labels. And once I had that, then I just assumed that it's probably pretty close to being as level as it's going to get. So yeah, I'll check voltages, see where we stand with all of that, and come back. What I want to do now is take the measurements from the center column and move them over to the left-hand column in order to establish a new baseline. Then I'll take my new measurements and plug them into the center column so that we can compare them. The lack of change in the red circles suggests that replacing the last half dozen or so capacitors did not impact the voltage levels at all. That's not to say that there were no improvements, just that those improvements weren't actually voltage related. I'd like to focus on the readings around V3 and V4. We'll go in and take a look at the resistors surrounding those two tubes, and after measuring every resistor that impacts the two valves, we are left with 3 that are circled here in cyan that measured out of spec. R23 and R25 might have the most direct effect on V4. Most of its pins measure over 10% out, but it's also possible that R21 could affect it, and at the same time it certainly could be what's dragging V3's plate voltage down from where it sits in the circuit. After replacing those 3 resistors, new measurements show that 1 or more of these 3 resistors improved our cause. The plate voltage from V3 is now closer to spec than even V2, and the measurements around V4 are all spot on. What remains are the voltage readings right at the CRT, V1, as well as a few readings towards the end of one of the resistor runs. So now it may be time to revisit the elephant in the room brought up in earlier discussions, namely the questions raised about whether or not the voltages are valid for this machine version. If we look just above the V1 table, we see a couple of voltage levels at plus 170 and plus 160. And again, if we look to the right, just beneath R10, circled in cyan, we see other voltages posted at minus 170 and minus 120. In each case, there are levels marked early and late, which I would interpret to mean where the machine fell in the production runs. The question becomes more significant when we consider that if our machines line up with the early vintage machines, our measurement at R3 becomes very close to falling within limits, and in fact was within limits on our very first baseline. In order to answer that question, we need to know a little more about the history of the 164E. Clearly the precursor was the 164, but as it turns out, its development didn't just jump from this to this. On the right, we see the popular model of the 164E, and on the left, we see my original 164. Before this classic look came along, the 164 looked like this, which uses the same case and looks just like the original 164, except it has a test port on the right side directly across from the external sink. We pointed out this extra circuit when we compared the schematics early on. Looking closer at the plate, we can see that it's labeled as a 164E and supports export voltages. But even before Dumont moved in this direction, there was this. And this is either a prototype or one of the earliest 164Es, because it looks like they just pulled a 164 off the shelf and drilled a hole in it for the new test port. A closer look reveals that the E was stamped into the tag, and the serial number is only about 150 or so later than what's on my scope. So it would appear that at sometime around serial number 2600, Dumont switched to the 164E. Note also that the tag indicates that the device supported only domestic power, just like the 164. What all of this does is bring us back to the notion that the 164 is more likely related to the early vintage of the 164E than it is the later one, if it can be related to any of them at all. But under this assumption, we can see that the R3 reading is very close to spec, and we can now turn our attention to R9 through R11 in order to bring it in closer. The measurements on those 3 resistors indicated that only R9 and R10 were out of spec, so they were replaced, which did wind up bringing the measurement at R3 within the acceptable 10%. Ultimately, I wound up replacing another 5 resistors, 3 of which were out of spec, and another 2 which I damaged while lifting a leg before measuring them. So after changing a whole lot of resistors, after changing out all the capacitors, I still see that astigmatism on the right hand side. You can see that the width of the trace is a lot thicker on the right hand side for those waveforms that are moving away from you than the ones on the left-hand side moving towards you. So I made it through probably most of the stuff that I can do, and I haven't really seen any improvement in it yet. So thought I'd report it. One of the things I find myself going back to are the design differences between the 164 and the later export version. And when we take a closer look at the area of the horizontal and vertical gains, we can see that the E version adopted a kind of symmetry between the two circuits that is not fully developed in the 164. Whether or not the design was intended to create some sort of balance between the circuits, I really wouldn't know. But it is worth considering that they both spec 4 meg pots at R3 and R4. They both spec 0.05 microfarad capacitors at C6 and C7, but the 164 does not spec a 5 meg resistor at both R15 and R16 as the E version does. And this is also reflected in the 164's part list. I'm not suggesting that some sort of 85-year-old misprint took place, since everything is not truly balanced in the older scope. Note that the voltage levels at R3 and R4 are not precise polar opposites as they are on the 164E. But I am thinking that an experiment where we replace R15 with a 5 meg resistor might be kind of fun. Okay, I'm still going to pursue trying to make the astigmatism issue a little bit less, although it's improved a little bit when I put the 5 meg or 4.7 meg resistor in. I'm still not sure where I'm going to wind up on that one, but a couple of other issues have come up, and one of them involves the sync control. I was turning it and I heard a little bit of a snap, and now I'm getting this on almost the whole range on the sync, which I don't think is a good thing. And then when it comes on, there's a spot there, it goes out again, a weird spot there. Get it back to where it's working. I've checked it, and it looks to me like it's shorting out when I have it turned in certain positions, and then it's clearing itself up. This is one of those, it's going to be tough to get it off, because it's one of those that I haven't been able to even remove the knob on. These two, vertical position and the sync. The set screw is really locked in place there, so I may wind up having to actually cut them off, which would be a real shame. But so I've got two issues. One is with the sync, and the other one is with the, I still have issues that I need to work out with that astigmatism. But here's another thing that I'm not sure is correct. If I turn this, it's hard to see, but you can see that it moves horizontally as I turn up the brightness. It shifts. So, and I don't think that should happen, because pins 1 and 3 on this thing shouldn't be changing just because I'm moving the wiper across there. I don't think it should. I'm not an electronics engineer, but it's just the wiper value where the voltage divider is happening. So I don't know. That's another thing that I need to look at. So we'll look into the schematic and see how much of this might be related. This is the drawing I showed early on when I ran a comparison of the 164 against the 164E. But what we're focusing on now is that 0.1 microfarad capacitor at C24. Note that it's not equipped in the 164, but is equipped in the E version. I didn't purchase a 1600 volt cap for this project, but as it happens, I do have an extra left over from the ICO project when I restored my 460. It would be a simple low-risk experiment to temporarily strap that capacitor between pin 7 of the CRT and ground just to see if that revision had anything to do with eliminating noise on the trace. I put in a 0.1 microfarad capacitor. I didn't install it, I just sort of strapped it in there temporarily, tying it down with some leads I've got, and this is what I came up with. It appears to have gotten rid of a little bit of noise on the right hand side. It's not perfect, but it's better than it has been. I'm not sure if it comes out on video or not, but it definitely looks better than what I've had up until now. Problem, of course, is that capacitor isn't part of the original design. It didn't really come into existence until the 164E came out. You know, I'm pretty happy with it the way it is. You can still tell that it's blurry right along the edges where the bulb curves, and it's not that way on this side, although we can still see a little bit of the retrace on there. Haven't gotten rid of that. So what I'm going to move on to now is fixing the sync issue. Now I'm going to go in and try to repair it first to see if there's something obvious, like maybe a piece of wire or something has gotten in there and shorted it out. And if I can't find that, then I'll start looking around for a replacement. So the good news is that I was able to loosen the set screws and the 2 stubborn chicken heads and remove them without damage, paving the way to remove and repair the sink pot. Unfortunately, the 3rd stubborn knob remains immovable and will have to be replaced at some point. As the image shows, the sink pot came off easy enough, so I snapped this image as a reminder of how it was oriented. The first bit of bad news is that the pot wire is bent out of shape and the wiper only comes in contact with it intermittently. I tried to bend the wire back into shape, but only made the situation worse, so I started shopping around for a replacement. The second bit of bad news is that, unbeknownst to me, the grid cap on the horizontal amplifier was precariously loose, and when I went to remove it so I could get to the sink pot, it fell off, and I couldn't get it to make contact again. So I put in an order for a new 6C6 as well. It would take about a week for both parts to arrive, but when they did, I had the scope back up and running within a few short minutes. So fortunately, I was able to work my way back to where I was before breaking the sink pot. Returning to our schematic, we see the 2 broken components in orange. The sink pot snapped under normal use, and the cap for the control grid on the horizontal amplifier broke when I removed it to gain access to that sink pot. Moving to the upper right, we see 2 components in orange that I installed trying to clear up the astigmatism on the horizontal trace. Right now I'm leaning towards removing C24 because I'm not really sure that it helped at all, and it isn't spec for the 164 anyway. One other thing I wanted to discuss has to do with the horizontal positioning, which seems to be impacted when I turn up the intensity. The direction of the movement along the horizontal trace is to the right, which is in the direction of increased voltage. In this video, I was trying multiple configurations of the sync and sweep selections to see if the effect could be isolated to a particular configuration, but it happened across the board. It could well be that the effect is inherent in the design of the 164. Note that the wiper on the intensity pot affects the heater and the control grid. Lastly, if we look at R3 and R4, we see ohm readings that I took very early on in this project. The resistance falls far short of the 4 mega ohms called for in the parts list. In this clip, I'm checking the trace after replacing the horizontal and vertical positioning pots with a pair of 4 meg potentiometers. Unfortunately, I didn't notice any real improvement after that. Here we see some of the parts replaced during this project, including a new set of control knobs, 16 capacitors, about 10 resistors, and a broken CRT, potentiometer, tube, and handle. There are a couple of nagging issues that remain unresolved, but by and large the functionality of the scope has been restored along with the power levels. Along the way, a new set of drawings were also created. At one point I had toyed with the idea of repainting the case, but while cleaning it I stumbled upon some writing that I wanted to investigate in order to, perhaps, uncover some of the scope's history. The phone number is from somewhere in central Illinois, like Springfield, Decatur, or Champaign, but this scope dates back quite a few years before the direct distance telephone numbering plan came into existence. It's likely that the number was written onto the scope sometime during its working or shelf life. One can imagine a tester looking for a piece of paper to scribble something on it and just falling back on the scope as a tablet when one didn't present itself. Searching the web, I found no tech companies that went by the name BESM dating back into that era. It's very possible that these initials represent a department within a much larger research lab. I bought the scope on eBay from a seller located in Union City, California. And looking at the map, we can see that there's a very large government research lab located in nearby Livermore, the Lawrence Livermore Labs. I contacted the seller and asked if the scope came from Lawrence Livermore, and she said that she didn't know for sure, but that a lot of what they sold did come from that lab. Now, there is a research lab within the Department of Energy dubbed BES for Basic Energy Sciences, and within BES there is a materials research group located at Lawrence Livermore. So does the asset stamp BESM stand for Basic Energy Sciences Materials? I don't know. But I do know for sure that this scope predates BES, DOE, and its precursor, the Atomic Energy Commission. It wouldn't be unusual for a piece of old lab equipment to hang around for that many years before landing in someone's storage closet, though. I saw that happen myself when I worked at AT&T. I tried contacting BES to get some information on whether or not this is the type of stamp they use, but I didn't get any kind of reply from them. So Basic Energy Sciences, the Department of Energy, and the Atomic Energy Commission didn't exist when this scope was built. What lab preceded all of them? That would be the Manhattan Project, in which researchers at Lawrence Livermore played a vital role. I can't verify with any absolute certainty that any of this is true, but I can fabricate an image where Oppenheimer walks into someone's lab and glances at this scope to check his progress. Or maybe not, but thank you for watching.